Welcome back, everybody. This video we'll be graphing some functions. Function notation, f of x, you can just think of that as y. Whenever you see an f of x, think of it as y. And what we have here is a function in slope-intercept form. As you can see, negative 3/4 x minus 4. We can just let's get slope-intercept form up here so you can see the comparisons. So negative 3/4, we see how that is our m, our slope, and our b number, our y-intercept, is a minus 4. So in order to graph this, we'll put a dot at negative 4 on the y-axis, and to get the next point we'll go down 3 and to the right 4 to find our other point. We can then connect it with a straight line, and that is how we can graph the function negative 3/4 x minus 4. Let's look at another one here. So 3/4 x plus 2. So here's our slope of positive 3/4 this time. We'll just point out the slope here. In this case, we'll be going up 3 and to the right 4 to find the x point. Y-intercept b is 2. We're going to put a dot at 2. And then we'll use the slope to find another point. Up 3, 1, 2, 3, right 4, 1, 2, 3, 4. And let's make another straight line connecting these two dots. And there's the graph of our function. Look at another one here. How about a decimal? Now notice the decimal, negative 0.25. It would help us to write that as a fraction. Negative 0.25 can be written as negative 1/4. And notice our y-intercept of 4. We'll put a dot at 4 on the y-axis. And from there we will go down 1 and to the right 4. The negative slope saying go down 1 to the right 4. There's our second dot, and we will connect those with a straight line. And there we go. Graphing functions, just like graphing lines, it's just the notation. F of x can be substituted with a y. Now if we need to, we can graph these on Desmos. Here I have them all plugged in. Desmos does like to read f of x right as opposed to y. Here's the 3/4 x plus 2 function. That's how that looks. Here's the negative 0.25 x plus 4. And then finally here was the negative 3/4 x minus 4 down here. So yeah, use desmos.com/calculator for quick and easy graphs. Alright, now we'll look at a couple story problems here. It says a painting crew bought 30 gallons of paint for a job. The crew members used 3 gallons of paint per hour until they used all the paint, which sketch represents the situation. So the y-axis is the number of gallons remaining, and at 0 hours they had all 30 gallons. So we would need to look for the one that has a y-intercept of 30, and see these two right here, the second and the fourth one, have that. Now it says they used 3 gallons of paint per hour until the paint was all used. So the slope is technically negative 3, and notice all 4 of these have a negative slope. To find that x-intercept, where that's going to meet the x-axis, what we'll do is take 30 and divide it by 3. 30 divided by 3 is 10. This will tell us that 10 hours is when the paint was all gone. And then we can finally see here this last one fits that situation perfectly. Notice the y-intercept was 0.30. When the paint was all gone, the x-intercept 10, 0. And then another one similar to this, just without the aid of the graph, says a manager of a plant nursery bought 120 pounds of soil to use for potting plants. The manager can put 5 pounds into each of the small pots, 12 pounds into the large pots. We got 2 pots, small and large. The manager made a sketch to show the line representing the different combinations the pots can be used. X-axis is the small pots, y-axis is the large pots. The manager labeled only the intercepts, which points to the manager label. Well, let's first get a rough sketch here of x and y axis. We'll use green. because we are talking about plants. The y-axis is the large plants, and the x-axis was the number of small plants. Alright, now there's kind of two situations here to label only the x and y intercepts. We have 120 pounds, and let's assume that the manager of the nursery is only going to use large. Well, to find out how many, we would have to do 120 divided by the 12. 120 divided by 12 we can see is 10. So we would have a y-intercept of 10 here. And the coordinates would be 0, 10. Alright, we're going to do the same thing for if he only used small pots. So we have 120 pounds of that, and we would have to divide it by 5. Then 120 divided by 5. Do that on the calculator real quick, we get 24. So if they use just small, it would be 24. Okay, and the coordinates 24, 0. Now there is a line, as the manager did, he made a graph, and if we connect those two with the line from here to here, this line represents all the coordinates, whole numbers only, of the combinations of small and large that he could use. Meaning if he only wanted small, he could do 24 small, 0 large. If he only wanted large, he could do 0 small and 10 large. So those coordinates would be 0 and 10 and 24 and 0. Alright, thank you for watching. Hopefully this clears up how to graph functions and a couple applications of them. Thank you for watching.